Hi all, welcome back to my channel pyspark Pearls. So in this video we'll be discuss about out of memory issues in Spark Executor. This is the part 2. In the part 1 we have discussed about out of memory issue in Spark driver. That link I will be sharing in the description and also in the I button. You can check from that. So let us begin this session. So before uh, discuss about the out of memory issue in the Spark executor, we should be knowing how the memory is actually distributed in the Spark executor. Then only we can get the causes and what would the possible solution of OOM issue in Spark executor. So first of all, let's visualize this diagram. Let me expand this screen. So we can see this is how the Spark memory is distributed, right? So suppose this blue box, this can be considered as an executor, and inside which we have reserved memory. Then we have unified memory, which is the 60% of the remaining memory after subtracting this reserve memory. After Spark 1.6, like 1.6 plus versions, the uh, reserve memory by default it is fixed to be 300 MB. Like it, all the Spark, by Spark objects and whatever things Spark requires to execute a task. So it is defined in reserved memory. Then this is the user memory, which is 40% of the remaining memory. Okay, so you can see this, and you can take this screenshot for your reference. And while interview, that this can be a possible question like, tell me like how the Spark executor memory is distributed. So you can see that this is 60%, then this is 0.5 of the unified memory. This is like executor memory, and the storage memory is 50-50%, right? Of the 60, that means this can be 30%, or this is 30%, like we can say that. Okay, so you can check this. Now let us see each and every memory uses and in detail actually. So we can check this reserve memory. So reserve memory we have seen, this is our reserved memory, the 300 MB part. Okay, so reserved memory used for the memory reserved by the system, and it is used for the Spark internal objects. As I have already told, like all the PySpark Spark objects, reserve memory holds them. Then after 1.6 version, it is value of 300 MB. The 300 MB is fixed. Now one thing we need to check and note that if the executor memory is less than 1.5 times of the reserved memory, that is 1.5 into 300, it is less than 450 MB, then it is going to cause an error, and that will be this Java lang illegal argument exception executor memory. This one must be at least this. Okay, this is around like 450 MB. Please increase the executor memory using this configuration. This should be like suggestion the Spark is providing. So we should be taking care that at least 450 MB of executor memory should be there. It is always more, right? Whether you're working in community edition on Databricks or you're working on your live projects anywhere, this is more. But just Spark has defined the limit, right? So this is the reserved memory, and what purpose it serves the storage of internal Spark objects. Okay, then we will be seeing the user memory, that is 40%. Let me expand this. Then user memory is the 40% of the Spark memory. It is used to store the UDF for the RDD conversion operation and RDD dependency, and that the lineage of that. So it is kept in the user memory and Spark internal metadata and all. So it is defined in the user memory. It stores that. So for example, like we can say Spark can rewrite aggregation by using the map partition transformation to maintain a hash table for this aggregation to run, which would consume so-called user memory. This we can, it is very clear from the example. Then this memory is not managed by Spark. Spark will not be aware about this or for this maintained for memory management, memory segment, right? Spark is not aware, right? So we should be carefully using this memory UDF. That's why we know suggest that UDFs are not much efficient, and we avoid using UDFs in projects, right? Then let us go and see the unified memory. This is the main memory which um, we consume from the Spark executor, and this is the memory segment where the executor out of memory exception are bound to happen, right? Let us see this first. Let me zoom this image. So unified memory is 60% of the total memory. and this is 50% of the executor memory and 50% of the storage memory. Okay, now let us just go through this in detail. I have explained both storage memory and executor memory. So like it is the memory pool which is managed by Spark. User memory is not managed, but Spark manage this unified memory. So, before this Spark 1.6 version, there was a static memory distribution, but now when unified memory distribution is there, like it is a dynamic kind of, like the executor memory can consume some part of the storage memory, or storage memory can consume some part of the executor memory. So this depends on those certain factors. So that I will be discussing later in the upcoming slides. So let's discuss. Okay, what data is stored. So Spark memory is responsible for storing intermediate states while doing task execution like join or storing broadcast variables, right? Then all the cache and persistent data that we send it will be stored in the storage memory of the unified memory segment. Then Spark tasks in two memory regions. Like in the execution region, the Spark holds data for the shuffling, join, sort, and aggregation, like all the execution related data. And the storage is like whatever data we cache into the Spark memory, it will be managing that, right? Then the boundary between them is set. Spark.memory.storage fraction parameter, which defaults to 0.5 or 50%. Already I have set that 0.5 of the unified memory. Then we will see the use of storage memory explicitly. Storage memory is used for storing all the cache data, broadcast variable, unroll data, etc. Unroll is essentially a process of deserializing serial data. Like for example, um, in the disk we are storing data in the deserialized way, I guess. It's deserialized. I'm just little bit confused, but you can check. Okay, but when you are storing in the cache form, then it is in the serialized way, right? As a serialized manner. So that in disk, if we cache some data, if we cache some data in memory, it will be more than the disk, right? So this is one thing. Then any persistent option that includes memory in it will also store in this segment. Like persist have five memory options. So some has like memory and disk, memory only, disk only. So like this, if we have memory and disk option, then some part of the memory will be stored in the storage memory of this unified memory section. Then Spark clears space for the new cache request by removing old cache objects on the least recently used LRU mechanism. Okay, so let me just give you an example of what is LRU mechanism. Let me create one diagram here. So suppose this is our storage memory, right? And we have let me create multiple boxes here. Let me no, give this some different color. Let me give this color. So suppose some blocks of storage memory are filled, right? So what this LRU mechanism means this that is least recently used. Okay. So what will happen? This storage block section, like which block section, like which part of the cached memory is least recently used. Suppose this part of the cached memory is least recently used, right? This part of the cache is not used. So whenever Spark will be clearing this memory, this part of cache will be gone first. Okay, this will be gone first. Then if this is there, then this will be gone next. So like this, the Spark is going to clear the memory, right? I hope you got it. If you have any doubts, you can ping me in this mechanism. This is like self-explanatory, least recently used. Okay. Then the execution memory. Okay. The execution memory is the main segment. Both storage and execution memory is main, but execution memory is the main thing. Like where we tend to get some, out of memory exception because of data skewness, or when we are broadcasting a large data set, a data frame into the executors, then we can get. Okay, then in joins mostly we get if data is skewed. So we can get the Spark execution memories for storing objects required during the execution of Spark, the shuffling, reshuffling the data, repartitioning of the data. The example I've already given, it is used to store shuffle intermediate buffer on the map side in the memory, right? Also it is used to store hash table for the hash aggregation step. If the hash hash aggregation or hash join is done, hash shuffle join is done. So like that. Suffer has join is being done, so then we are using this execution memory. Then pool also supports spilling on disk if not enough memory is available, but this blocks from this pool cannot be forcefully evicted over the other threads. So like there might be like after reading this line, the pool also supports spilling on disk. So then after reading this line, there should be a doubt in your doubt coming in your mind, like if we can spill the data on the disk, right? Then why there will be out of execution, out of memory in the execution memory side. So that also I will be discussing. Just keep watching this video and be with me. I will be discussing this. This is actually interesting concept, right? Data skewness will be coming in, and it will be good concept to learn actually. Then execution memory tends to be more short-lived, like it is very short-lived, as an and when the operation is as an action is completed, then this is cleaned, right? So that next action can be performed, right? Then this is the first two lines. Storage memory can borrow space from the execution memory only if blocks are not used in the execution memory. Like suppose as 0.4% of execution memory, executor memory is covered, and executor memory requires you know more space. So what it will do, it will uh, this executor memory, this storage memory, this will take consume this much part, right? This will consume this much part, then storage memory will become bigger, right? And similarly the second step, what it is, second step is execution memory can also borrow space from the storage memory if the blocks are not used in the storage memory. So we can see this executor memory requires more space, it can grow bigger and it can consume storage memory. Like this it can done, right? It can be done like this. Then if the blocks from execution memory is used by the storage memory and execution needs more memory, it can forcefully evict the excess block occupied by the storage memory. Now let us check this concept. So suppose this storage memory, it has consumed some part of the executor memory, right? Now the tasks are running in parallel, and suppose a large y transformation, or we can say a transformation is called upon the task, and executor is what executor memory needs, right? Memory needs to shuffle the data. So suppose it requires like suppose it is working currently on like 0.3% or 30%, right, of this out of this 50%. So then what it will do, and it requires whole 50% of data, then what it will do, it will just push the data, it will push the storage memory. And this I've already explained the concept, right? The LRU concept. And the executor memory will be cleared, right? But the vice versa, like if blocks from storage memory are used by the execution memory and storage needs more memory, it cannot forcefully evict the excess block. That is, if executor memory has blocked some part of the storage memory, okay, and then we are trying to cache the data, then it cannot evict the storage memory, right? It cannot forcefully evict the excess block occupied by the execution memory. It will have less memory area, it will wait until spark releases the excess block stored by execution memory and then occupies them. But execution memory can evict the storage memory, right? So this is the concept. Executor can evict. See, you can see the E and E, right? Executor can evict, storage cannot evict. This is the concept here. I hope it is clear, and you can just read my lines, the lines which I have pasted here. These are like self-explanatory. If you will go through it, this will be like more than enough to understand the concept, right? And so many interview questions can come up. The supports like this question can be asked in an interview. Like suppose the execution memory has taken some part of the storage memory, right? And we need to cache some data. Then what will Spark do, right? Then the answer will be very short and sweet. The Spark will only wait so that the execution is finished and it releases the access block stored in the execution memory, right? Then only the caching of the data, whatever data we are caching, it can come in the storage memory. Until and unless the task or the execution is not completed, storage memory cannot evict the execution memory occupied, right? So this is very sweet and simple answer. Our concept should be clear actually there. Now let us take a normal example. Like already, if you have understood all the above slides very clearly, then it is very okay. But just suppose I'm giving you an example, right? So like we are taking considering 5 GB of the executor memory, right? So java hype memory is gvm memory is 5 GB. That is around 500 5120 MB. Then reserved memory is 300 MB. This is reserved memory. Usable memory is Java heap memory minus reserved memory. That is around 4820 of MB will be remaining with us. Okay. Then user memory. User memory, this one, 40%. So this is around zero point 0.4, that is 1928 MB will be there. Okay. Then Spark memory, that is unified memory. Spark memory, unified memory, you can see, it is the same thing. Then it is unified memory will be 2892 MB, around 4820 multiplied by zero point 0.6. Then the storage memory will be 1446 MB, and execution memory will be 1446 MB. 0.05, right? It is divided equally. So this is nothing much. You can take this. There might be some question like explain, how 5 GB of executor memory is divided, and that is the first question which we discussed. Like explain the storage, how the executor memory is divided. So you can give take this example, take example of 5 GB, 10 GB, whatever suits you, and you can just change the value and you can get the answers, right? Now let us discuss some concepts like what are the out of memory reason for the executors. So we can see if the executor is allocated insufficient memory, it may not be able to handle workload. Then data skew is there. Okay, uneven distribution of data amount partition. This is data skew, and here the data spill concept is also I will explain in this slide only. Then unoptimized code might be there, right? We can just optimize the code and avoid shuffling, and then you can avoid out of memory issues. Too many concurrent tasks is running the executor memory, then it may lead to then large broadcast will that already discussed. Like if a large variable is broadcasted, right, into the in the executors, then it may cause out of memory. Now let us discuss this second point, data skew. Okay, let us suppose we are having this executor memory, right? This is the executor memory I'm giving. Okay, let me name this also. This is the executor memory. Okay, I'm giving this as executor memory. Okay, this is the executor memory. Just suppose. Okay, then we just suppose there are like let me change the color also. There are some tasks running in this executor memory, right? And just suppose we are joining two big data sets. Okay, and the data is skewed over there. Okay, and let us suppose while joining two data frames, we are having some values. What we can say, like suppose the data is skewed, and for the ID one in DF1, we can say that for ID1 we have like we can say like there are 1,000 records, 10,000 records. Okay, and in DF2 we have like for ID2 we have ID1 we have like uh, 10,000 records. Like we can say that 15,000 records. We should consider, right, 15,000 records. And for ID2 it is like 200 records. Okay, then for here also in DF1 ID2 is like 300 records, right? Then ID3 some 400 records, here also 400 records. So like you can see like for ID1 the data is unevenly distributed. The data is skewed, right? Then uh to avoid the data spilling will happen for different partition, right? Suppose this id2 is stored in id2 cannot be stored. Okay, and so id2 can be spilled into the disk. But what if id1, when id1 and id2 this comes in the same partition, and the executor memory is not enough, you know suppose this executor memory blocks is not able to occupy all these id1 values. Then it cannot happen. Like some part of the id1 can come to this executor memory and like 4 to 5 records can be spilled. Like this, it cannot happen, right? That will be a different thing. Then it will cause out of memory execution because of data skew. So to solve this, we can do repartitioning of the data, right? We can do repartition, then we can do salting. Okay, so like this concepts we need to apply to avoid this executor memory out of execution. So I hope you got it, and I hope this will help you understand what all things are there. So I hope you liked it also, like my explanation. Then these are the possible cause for getting out of memory exception in executors of Spark. Then let us come through the solution of that, right? Solutions are very easy, like increase the executor memory, right? We can increase the executor memory. Then data repartitioning, as I've already said, if data SQ is there, this I have explained in very easy way. Uh, then optimize code. It is the basic thing, right? If we want, we can optimize code, avoid unnecessary stuff links. This can avoid out of memory exception. Adjust parallelism. Okay. Then optimize broadcast variable. We should not be broadcasting a very large variable. So that all things we can take care, and then that will be some solutions and some problems I have made here, given here, so you can discuss it with the interviewer. Then you can discuss this example with the interviewer, and this will be like more than enough to know this is a good session for you to understand the memory distribution, then some out of memory causes, then the solution to that, and everything I've explained in great detail. So you can watch this video, share with your friends who are going to give interview on distributed computing, especially if they are giving it on the basis of Spark. So this is one of the core concept of Spark, right? How the memory is distributed and how the out of memory occurs in executor, and how we should overcome that. So I hope you have liked my video, and please subscribe my channel and let me know your feedback. They're very important to me. And yes, keep supporting, keep sharing, and subscribe, comment, and like. That is all my request to you. Thank you, and keep growing.